Okay, so let's tackle the first really big abstract concept of statistics, and that's standard deviation. Um, and before you get too overwhelmed, be sure to know that I'm going to help you figure out which things are important to focus on and which things are not. So this is some formulas. This is actually the sample variance because it's the letter S instead of sigma. Some formulas. This stuff, not so important. So here's a comic. I'll pause so you can let it sink in. It's just it's really too much unless you're going to specialize in statistics. And I'm not really even sure that it's that helpful. So we're gonna take a look at what does matter. And even this, which is like a step-by-step process, yeah, you could do it. I know that every one of you could do this, but I think it would just get caught up in the numbers and formulas and not really even know what's going on. One thing I do think is important formula-wise is to know that the standard deviation is the square root of the variance. So if you have variance, you can take the square root to get standard deviation. If you have standard deviation, you can multiply it by itself or square it to get the variance. So that connection between those two, that they're essentially the same uh, value, it's just one squared and one is the square root of the other one, that I do think is important. But in terms of concept, what is the standard deviation? Well, let's think of it this way. So there's not an easy way to explain it, but I think this gets at the concept of what's going on. So let's say you had these five people and they all took the SAT. We have their reading scores available here. So the higher the score, the better they performed on the test. Um, the first thing we want to do is take the mean, the average. So we add the five numbers, divide by five. And that's what you see here at this asterisk 548. This is a way to represent sample mean or sample average as x with a bar on top of it. So we see that that's the average, and that's okay usually. But then what's the standard deviation? Well, what's deviation? Before we get to standard, deviation just means how far away from normal is something, or the average. Well, if we look at this particular score, that was 490, and the average is 548. So if we subtract those two numbers, we get that the deviation was negative 58, that this particular score was 58 points away from the average. And then maybe we look up here at this one, the 650, so quite a bit above the average here. And how much? Well, we take 650 minus 548, and we find out that the deviation, the distance away from the average, is 102. So no matter how big our data set is, we could always do this process where we first find the mean or the average, and then we figure out what everybody's deviation is, how far away they are from the average. And then standard, which means like common or typical, standard deviation is about how far on average are people away from the mean or are data points away from the mean. So if we say a standard deviation is 1 or 2, then almost everyone is just a couple points away from the mean. If we say standard deviation is 100, that means the data is spread out quite a bit more, and on average-ish, the data points are about 100 points away from the mean. So the larger the standard deviation, the further the points are spread away from the mean. The lower the standard deviation, the closer everything is clustered around the mean. I know that's still not crystal clear, but it gives you a vague sense. It's basically how far typically are the data points away from the average. That's what standard deviation is. Okay, some things you should know about standard deviation. Um, it measures, it's in a connection with the mean. In other words, the mean is part of the formula. And even if we don't get into the formula in detail, you need to know that the mean is somewhere in the formula, which tells us if we don't have the average or the mean, we can't find standard deviation and we can't find variance. They're based on the mean. So why wouldn't we choose to use the mean as a measure of center? Well, remember, it's not resistant to outliers. So if we have really skewed data or data with some really high or really low values, we might not want to use the mean. And if we don't use the mean, we really can't use the standard deviation because you have to have the mean in order to calculate standard deviation. Another thing, standard deviation, because it's the square root of the variance is something squared. So like notice here, anytime you square something, it has to be 0 or positive. It can't be negative. Once you multiply something by itself, it has to be positive. So when you take the square root of that, you also have to be positive. So standard deviation can never be a negative value. If you see a negative value, that's not a valid standard deviation. Anything 0 or positive, 0 if all the data points are the same exact value, it could be 0. Or if they're somewhat different, then it will be positive. It could be a little bit positive, or it could be hundreds of thousands of something, but it has to be non-negative. And then along with that, not only is it non-negative, but the units, so standard deviation will be measured in the same units that the original thing is. So if we're looking at height of adult males in the United States and we measure it in inches, standard deviation will also be in inches. The variance, which is standard deviation squared, that would be measured in inches squared. If we were looking at weight in pounds, the standard deviation would also be measured in pounds. The variance would be measured in pounds squared. And because we want to deal in the original units, it doesn't really make sense to talk about someone's weight in terms of squared pounds. Just talking in terms of pounds makes much more sense. That's why we typically use the standard deviation instead of talking too much about variance. And then, as I said up here, just like the mean, standard deviation is not resistant to outliers or skewed data. So if you have data where there's a really long tail on one end, or some really high values or really low values, you can use it. You can still calculate it, but you have to realize that those extreme points are probably going to influence that standard deviation quite a bit, just like they do with the mean. So there is another alternative that we'll look at in a separate video. If we want to measure the spread in a way that is resistant to outliers, there is something else we can use. Okay, let me finish. Like I said, I know that this is pretty theoretical, so let's look at a specific example of how I might use standard deviation to understand a particular class and know what kind of examples to use, what to be very sensitive about. I'm gonna click on this here. And what I did was ask, this was a couple years ago, I asked a bunch of stats students, go ahead and just I asked them to rate. So I asked them to rate their beliefs or their status on a bunch of things on a scale of 0 to 100. So 0 or 1 was like absolutely not, and 100 was very much so. So you can see some of the things. And I tried to get some interesting stuff. So lonely, 100 would be completely feeling lonely. Loving God, 100, absolutely believe in a loving God. 0 would be absolutely do not believe in a loving God. Bible is true. How extroverted you are, how much you believe in yourself, supported by friends you are, how at home you feel at EMU. And there were a couple classes. That's why you see some missing data here. How necessary church is, and so on. So these are all ranked on a scale of 0 to 100. So instead of just looking at all this data to start, it's kind of overwhelming. How do I make sense of all these numbers? Well, what I'm going to do is I'm going to insert 2 rows. And the first thing I'm going to do is get the means. And so this is fairly easy. I use, average of, I'm just going to select the data here. Let me select all the way down so I get both classes worth of data. And then I can drag this across here. And those numbers are a little nasty, so I'm going to just change them to number. And then I'm also going to do something that I like to do here. When I like to see patterns, I like to see it in terms of colors. So I'm going to apply what's called conditional formatting. I'm going to put a color scale. Let's make the minimum value red, maybe, and then the maximum value could be blue. Okay, that might be a little hard to see. I'm going to make that a little lighter just so you can see pretty clearly. And then that's a little there. I think this should. Okay. So first thing is I want to know the measures of center. I want to know roughly where, as a class, people are. So I might start off by looking at the really high ones. So I see that the highest one here is 87, followed by 86, 86. So as a class, these particular two classes, um, they seem to rate their home life as pretty good, close to parents, that they were very close to parents, and that they believed in themselves. Some of these actually surprised me. I thought these numbers would be lower, um, because I thought in general some of these issues were tricky with students of college age. I know they were for me personally. Um, and then I might look low. So read the Bible. I noticed right away that that's extremely low. That on average, on a scale of 1 to 100, these two classes read the Bible 21. So even though this is a Christian university, I can see that that's not really represented, at least in terms of how much the Bible is read. On the other hand, I can see that the average score for belief in a loving God is 79. So I can see that there's probably some disconnect between people's beliefs and at least how they express that in terms of reading the Bible. So these all start to give me a real nice picture of the class average. But what I don't know yet, the missing piece of information is how much do the classes really cluster around that mean? And pretty much everyone in these two stats classes are sitting very close to the mean. And how much is it really spread out, that there's a lot of differences within the class? So that's where I'm going to go to standard deviation. And I'm going to do it P, population, because if I'm only concerned with these two classes here, not trying to generalize it to a larger population or something, I'm going to use an entire population, not oops, watch this. Grab that, press escape. That was one off in my, where I, the formula. Okay, so now this is the standard deviation for lonely. Pull that across, just like before. I'm going to go to format, number. I'm going to, oops, sorry, format, number, and I'm going to go down, just grab this one. That'll make it nice and clean. I'm also going to go format, do the conditional formatting with this one. Let's do minimum value blue on this. I'm just kind of arbitrarily choosing colors here that hopefully for colorblind work. Okay, so this is a little trickier, but it's actually just as valuable, if not more valuable. Now I have the standard deviations. What does this information tell me? So let's take a look at home life. Home life is a 10. It's my lowest standard deviation here. This doesn't mean that home life is horrible in these students. In fact, on the opposite, the average home life is 87. So the average home life is rated as very good. What the 10 tells me is almost every student is hovering right around that really solid home life score. And to be honest, I found this very surprising. I didn't expect this. That 10 doesn't tell us where the score is. It tells us how much the students are clustered around it. On the other hand, I can see that 33, church necessary, foreign culture exposure, O's and students' loans. The fact that these numbers are very high tells me that there's a wide range within our class, that this is a very controversial issue, whether or not church is necessary. The amount that students owe in loans is very different. There's some who don't owe very much at all, and some who owe a lot in the class. And the amount that they've seen foreign culture, maybe they've gone on cross-cultural, they haven't, or haven't had those experiences. So the standard deviations here really do give me just as much valuable, different type of information as the means.